What, that? Don't worry about that, we'll get onto that later. Hi there, Joshua here. So I was at school, I was learning about circles, and my maths teacher said to me, she said, does your calculator have pi on it, she said. I said, well, I did leave it in the kitchen last night, so possibly a few crumbs. Let's get on with the lesson. Right, so welcome to lesson 2 on transformations of graphs. In this lesson I'm going to talk about the f of x notation that you sometimes see when you do this topic. It's pronounced f of x, and sometimes you'll get a question and there'll be a graph drawn, but they won't tell you what the equation of the graph is. They'll just say, here's a graph of y equals f of x, and then they might say something like, can you draw the graph of y equals f of x plus 10, or something like that. So I'm going to talk about this notation, I'm going to explain what it is. But before we do that, I'm just going to do a sort of a quick recap of what we did in lesson 1. I'm going to do a slightly harder example than anything we did in lesson 1. I've drawn 5 copies of the same graph. The graph I've drawn is y equals x squared minus 4x. And I'm just going to transform that graph in a few different ways, just as a recap of what we did in lesson 1. I'll just draw one more copy over here. It's a quadratic graph, it's an x squared graph, so it's symmetrical, and it gets steeper as it goes up. And this one goes through the x-axis at 0 and 4, and the lowest point is 2 minus 4. So this is the graph of y equals x squared minus 4x. So I'm just going to transform it a few different ways. So what would I have to do to the equation of the graph if I wanted it to move up 4 places? So if I wanted the graph to translate up 4, remember a translation is just a movement in a straight line. If I wanted to do a translation up 4, what would I have to do to this expression for that to happen? Correct, I'd have to stick a plus 4 on the end. So I'd have to take the original equation, y equals x squared minus 4x, and I'd just stick a plus 4 on the end. And that would cause the whole graph to move up 4, because all the y values would be 4 bigger. So all the points would be 4 higher, basically. So this point would move up 4, this point would move up 4, this point would move up 4. There's no scale, so I'm just imagining moving some points up 4. This point would move up 4 maybe to there, this point up 4 to there. So the new graph would just be the original graph, just translated 4 places up. If you stuck let's say a minus 4 on the end, then the graph would move 4 places down. So let's say I wanted to take the original graph and I wanted to stretch it. I wanted it to stretch vertically by a scale factor of 2. In other words, I wanted all the points to be twice as far from the x-axis. So let's say I wanted the graph to stretch vertically, vertical stretch, scale factor 2. What would I have to do to the expression on this side for that to happen? That's right, you'd have to double the expression. So you'd have to take the expression on this side. Well, I'll just write the equation again, y equals x squared minus 4x. And you just have to double the expression on this side. So doubling the whole thing there. That would cause all the y values to double, so all the points would be twice as high or twice as low as they were before. So this point would be twice as high, twice as far from the x-axis. This point would be twice as high. This point would be twice as low. So these points are on the x-axis, so they wouldn't move. And the new graph would just be the original graph sort of stretched vertically by a scale factor of 2. If you wanted to squash the graph vertically, you'd have to multiply the whole thing by a fraction. Like if you multiplied the whole thing by a half, that would squash it down, and all the points would be twice as close to the x-axis. All the y values would be halved. But if you multiply it by a number bigger than 1, it sort of stretches it vertically. Right, let's say I wanted the graph to reflect in the x-axis, so to sort of reflect down in the x-axis. So reflect in the x-axis. What would I have to do to the expression on this side? Well, I'd have to stick a minus sign in front of it. So I take the original equation, y equals x squared minus 4x, and I just have to stick a minus sign in front of the whole thing. Now I could simplify that and get rid of the brackets. That's the same as minus x squared plus 4x if you remove the brackets. But I'll just leave it like that so you can see how it relates to the original expression up here. So sticking a minus sign causes the graph to reflect. All the negative y values become positive and all the positive y values become negative. So this point moves up here. This point moves down here, reflects in the x-axis. This point moves down here. These points are on the x-axis, so they stay there. So the new graph, well, the new graphs look something like that. Just the original graph reflected in the x-axis. Now if you notice, so far all the transformations I've done have been vertical transformations. They've all moved the graph up or down in some way. And you get a vertical transformation by doing something to the whole expression. So for example, adding 4 to the whole thing, or doubling the whole thing, or sticking a minus sign in front of the whole thing. So the next few transformations I'm going to do are going to be horizontal transformations. And if you remember from last lesson, you get a horizontal transformation by replacing the x's with something else. You've got to replace all the x's with something else for a horizontal transformation. So for example, let's say I wanted to move this graph 2 places to the right. Let's say I wanted to do a translation 2 to the right. What do I have to replace all the x's with for that to happen? So I'll just write the new equation, and I'll leave a gap where the x's were. Now it's a bit weird, but if you remember from last lesson, with horizontal transformations, what you need to do is the opposite of what you'd expect. So to move the graph 2 places to the right, you actually replace all the x's not with x plus 2, but with x minus 2. So you replace that x with x minus 2. You replace that x with x minus 2. And that causes the graph to move 2 places to the right. It's a bit weird. I did go into detail in lesson 1 as to why that happens. It's basically because to get the same y values that you had before, the x values now need to be 2 bigger than they were before. But if you want a bit more information about that, you can look at lesson 1. But replacing all the x's with x minus 2's would cause the graph to move 2 places to the right. So this point would move 2 to the right, this point would move 2 to the right, this point would move 2 to the right, this point as well. This point would move 2 to the right. So the new graph would just be the original graph translated 2 places to the right. So replacing x with x minus something moves it to the right, and replacing all the x's with x plus something would move it to the left. It's a bit weird. So if I'd replaced all the x's with x plus 2's, then the graph would actually move to the left too. So with horizontal transformations, what happens is the opposite of what you'd expect. Right, let's move down here. Let's say I wanted to take this graph and stretch it horizontally by a scale factor of 2. In other words, double all the distances from the y-axis. So let's say I want to do a horizontal stretch. Horizontal stretch. Let's say scale factor 2. What would I have to do to the expression on this side? Well, as I said, for a horizontal transformation, you replace all the x's with something else. So I'll just leave gaps where the x's were. And if you remember from last lesson, if you replace all the x's with 2x, that doesn't stretch the graph, it sort of squashes it and moves all the points 2 times closer to the y-axis. To stretch the graph by a scale factor of 2, if you remember, you have to replace all the x's with half x. Again, the opposite of what you might expect. So you have to replace this x with half x. You have to replace this x with half x. That will cause the graph to stretch by a scale factor of 2. Basically because the x values need to be twice as big as they were before to get the same y values. But again, I did go into a bit more detail in lesson 1 explaining why that happens. But yeah, this new graph would be that graph sort of stretched, so this point would move over here, twice as far from the y-axis. This point would move maybe over here, this point over here, so all the x-coordinates double basically. This point would move twice as far from the y-axis over here. This point is on the y-axis, so it doesn't move. So this is what the new graph looks like. And let's move down here. So let's say I wanted to cause the graph to reflect in the y-axis, so to reflect horizontally in the y-axis. What would I have to do to the expression on the right-hand side? So for the graph to reflect in the y-axis. Well, again, for a horizontal transformation, for a horizontal reflection, you have to replace all the x's with something else. And if you remember from lesson 1, to reflect it in the y-axis, you just replace all the x's with minus x. So you replace this x with minus x, you replace this x with minus x. and that causes the graph to reflect in the y-axis. So this bit moves to the right over here, and this bit moves to the left over there. So the new graph is just the old graph reflected horizontally in the y-axis. So that's a reminder of what we did in lesson 1. Right, so I'm now going to talk about the f of x notation that you sometimes see in this topic. So sometimes there'll be a question or an example where they'll have a graph, some sort of squiggle, they'll have a graph and they'll say this is the graph of y equals f of x. So they won't give you the expression. So f of x just stands for an expression involving the letter x, a calculation involving the letter x. You know, what you'd normally have on this side of the equation of a graph. So sometimes they don't tell you what it is, and they'll say something like, can you draw, or can you sketch the graph of y equals f of x minus 3? Or can you sketch the graph of y equals f of x plus 2 with an x plus 2 in a bracket? I'm going to explain what all this notation means, and then we'll apply it to transformations of graphs. So let's say in this example, in this example, f of x stands for x squared plus 3x minus 1. So in this example that I'm about to do, that's what f of x stands for. So whenever I write f of x, I just mean this expression here. I mean x squared plus 3x minus 1. So if I wrote f of x plus 7, what would this mean? Well, f of x plus 7 just means this expression with a plus 7 stuck on the end. So it just means x squared plus 3x minus 1 with a plus 7 stuck on the end. What if I wrote 4 times f of x? What would that mean? Well, it's kind of probably what you think. It's just 4 times that, basically. F of x just stands for this, so 4 times f of x just means 4 times that. So it's 4 times x squared plus 3x minus 1. Nothing complicated so far. What does minus f of x mean? Well, minus f of x just means that with a minus sign stuck in front of it. So it just means f of x, which is that, with a minus sign stuck in front of it. So it just means that. So nothing surprising so far. This is where the notation gets interesting, and this is what a lot of people I find don't understand. If I write f of x minus 2, with the x minus 2 actually in the bracket, what does that mean? Well, this just means, it means f of x, it means that, but with all the x's replaced with x minus 2's. So this just means you take that expression and you replace all the x's with x minus 2's. So instead of x squared plus 3x minus 1, it'll be x minus 2 squared plus 3 times x minus 2 minus 1. That's what this means. It means all the x's are replaced with x minus 2's. So I just find a lot of people don't understand the notation at all when they do this topic. If I wrote f of 4x, what does that mean? Well, that just means the original expression, f of x, but with all the x's replaced with a 4x. So it'll be 4x squared. So instead of x squared, it'll be 4x squared plus 3 times 4x minus 1. So I hope that's clear. I'm just replacing all the x's with 4x. That's what that means. Let's just do one more. F of minus x, what does that mean? Again, that means the original expression, it just means f of x, but with all the x's replaced with minus x. So it just means minus x squared plus 3 times minus x minus 1. So that's a bit of information about the f of x notation. Right, let's try and apply this f of x notation to a question about transformations of graphs. So in this next example, in this example I'm about to do, f of x is going to stand for a different expression. It's going to stand for x cubed plus 2x squared. So a different expression this time. So in this example, f of x is going to stand for x cubed plus 2x squared. So whenever I write f of x, I just mean that expression there. Let's try and draw this as a graph. So let's try and draw the graph of y equals f of x. In other words, y equals x cubed plus 2x squared. Let's try and draw that graph. The graph looks like this. It's just a very quick sketch of the graph. It gets steeper as it goes up, and it crosses the x-axis at -2, and it touches the x-axis again at 0. So that's what it looks like. So let's do some transformations of this graph, but using the f of x notation. So number one, let's draw the graph of y equals f of x minus 8. Let's draw that graph. Well, before we draw it, we need to think what this means. So f of x minus 8, well, f of x minus 8 just means that expression, f of x, with a minus 8 stuck on the end. So in other words, it just means y equals x cubed plus 2x squared. So that expression there with a minus 8 stuck on the end. So I'll draw the original graph first. This is the graph of y equals f of x. In other words, y equals x cubed plus 2x squared. We want to draw this graph where there's been a sort of a minus 8 stuck on the end. So what effect does sticking a minus 8 on the end have on the position of a graph? Well, it just moves the graph down 8, doesn't it? So the graph is going to be sort of shifted down 8 places, somewhere down here perhaps. So it's the original graph translated down 8 places. So number 2, let's sketch y equals 2 times f of x. Y equals 2 f of x. So again, before we sketch it, we need to think what that means. What does 2f of x mean? Well, it just means that expression, f of x, but doubled. So it just means, in other words, it's y equals 2 times that whole expression there, x cubed plus 2x squared. So let's draw the original graph first. So I've just done a sketch of that graph, x cubed plus 2x squared. Now, what effect does doubling the whole expression have on the position of the graph? Well, you're doing something to the whole expression, so it's going to be a vertical change, and it stretches it, if you remember. It makes all the y values twice as big as they were before. So it's a vertical stretch by a scale factor of 2. All the points are twice as high, or twice as low if they're under the x-axis, as they were before. This point's going to move way up here. This point's going to move up here. This point down here. This point and this point are on the x-axis, so they're not going to move at all. So the graph is just the original graph stretched vertically by a scale factor of 2. Something like that. So that's y equals 2 times f of x. Number 3, let's do y equals minus f of x. Y equals minus f of x. Again, before we draw that, we need to think what this means. Minus f of x is just that expression, f of x, but with a minus sign stuck in front of it. So in other words, it's the original expression, x cubed plus 2x squared, with a minus sign in front of it. So I'll draw the original graph again. So that's y equals f of x, this graph over here. And if you stick a minus sign in front of this expression, if you stick a minus sign in front of it, what effect is that going to have sort of on the position of the graph? Well, sticking a minus sign in front of the whole thing is going to reflect it vertically. So it's just going to reflect in the x-axis. So it's going to be a vertical reflection, and it's going to look something like that. Right, let's do a few over here. Number 4, let's do y equals f of x minus 1, with the x minus 1 inside the bracket. So let's try and sketch that graph. Again, we've got to think what this means. So f of x minus 1, when it's inside the bracket, it just means the original expression, it just means f of x, but with all the x's replaced with x minus 1's. So in other words, it just means instead of x cubed, I need to write x minus 1 cubed. Instead of 2x squared, I need to write 2x minus 1 squared. So it's just the original expression, but with all the x's replaced with x minus 1's. So I'll just, before we sketch it, I'll just sketch the original graph again, like that, something like that. So that's that graph. So what does this graph look like? So what effect does replacing all the x's with x minus 1's have on the position of the graph? Well, initially you may think it would move the graph one place to the... sorry, I should say, replacing all the x's with something else, it's a horizontal transformation. You may think replacing all the x's with x minus 1s would move the graph left one, but as we now know, the opposite thing happens with horizontal transformations, so it moves to the right one. So all the points move one place to the right. So this point moves over here, this point moves over here, this point over here perhaps, this point over here, this point over there. So it's the original graph shifted one place to the right, translated one place to the right. That's what f of x minus 1 looks like. Let's do a couple more. Let's do y equals f of 2x. So let's sketch that graph. Again, before we sketch it, we need to think what that means. So in other words, so what does it mean? F of 2x, if 2x is in the bracket, just means the original expression, but with all the x's replaced with 2x. So instead of x cubed, it's going to be 2x cubed. Instead of 2 times x squared, it's going to be 2 times 2x squared. It looks a bit weird leaving it like this. I mean, I could simplify it and get rid of the brackets, but I am going to leave it like this so you can see how it compares with the original expression, basically. So I will leave it like this, although it could be simplified. So the original graph is like this. That's the original graph just over there. So notice all the x's have been replaced with 2x. Replacing all the x's with something causes a horizontal transformation. But what effect does replacing all the x's with 2x have on the graph? Well, again, if you didn't know better, you might think it stretched the graph out by a scale factor of 2. But it actually squashes the graph by a scale factor of 2. Remember, with horizontal transformations, it's usually the opposite of what you'd expect. So it actually squashes it closer to the y-axis. All the points end up twice as close to the y-axis as they were originally. So this point moves over here, twice as close to the y-axis. This point over here, perhaps. This point over here. This point over here. This point here is on the y-axis, so it stays there. So you can see the original graph is basically squashed inwards by a scale factor of 2. So that's y equals f of 2x. Replacing all the x's with 2x squashes the graph inwards by a scale factor of 2. One more. Let's do y equals f of minus x. Let's sketch that. Again, what does that mean? That just means the original expression, f of x, but with all the x's replaced with minus x. So in other words, it means y equals minus x cubed instead of x cubed, and 2 times minus x squared instead of x squared. Again, I'll leave it like that, unsimplified, so you can see how it relates to the original expression. And to sketch that, I'll sketch the original first, as always. So that's that graph there. Now, replacing all the x's with minus x, again, it's going to cause a horizontal transformation. When you replace the x's with something else, it's always a horizontal transformation. And replacing them with minus x causes the graph to reflect horizontally. So the graph reflects horizontally in the y-axis. So it reflects across. So this side moves to the other side, just over here. And this side moves to the right-hand side. So it's just like that. So it's a reflection horizontally in the y-axis. Right, so for the last example, imagine you were given a question, and in the question it said, here's a graph of y equals f of x, but suppose the question didn't tell you what f of x stands for. So the question doesn't tell you what expression this is, so it sort of could be anything. F of x, we don't know what it is. I mean, the graph goes through minus 2 and 2 on the x-axis, and it goes through 6 on the y-axis. And then suppose the question said, can you sketch y equals f of x plus 3? Can you sketch that graph? Well, yes we can, because even though they haven't told us what f of x stands for, sticking a plus 3 on the end always has the same effect on the graph. It always moves the graph up 3. So we can still draw a sketch of this graph, even though we don't know what f of x stands for. So this point will move up 3 and it will cross at 9, so over there. This point will move up 3, this point will move up 3. So the new graph is just the original graph translated up 3. So what about if the question said, can you sketch y equals f of x plus 10? Where the x plus 10 was in the bracket. Can we sketch that? Well, again, even though we don't know what f of x stands for, we can sketch it, because f of x plus 10 just means that expression, f of x, but with all the x's replaced with x plus 10s. And when you replace all the x's with something, that causes a horizontal transformation. Replacing the x's with x plus something doesn't move it to the right, it actually moves it to the left. So replacing all the x's with x plus 10s is going to move it 10 places to the left. So this point's going to move 10 places to the left and cross at minus 8. This point's going to move 10 places to the left and cross at minus 12. So all the points are going to move 10 places to the left. So this is the original graph. Just extend this line a bit. So the new graph is going to cross the x-axis at minus 8 and minus 12. And it's going to look exactly the same, it's just the original graph shifted 10 places to the left. Right, what if the question said, can you sketch y equals minus f of x? Can you sketch minus f of x? Well, again, we can sketch that because even though we don't know what expression this is, sticking a minus sign in front of the whole thing, that causes the graph to reflect in the x-axis. It causes it to reflect vertically in the x-axis. So this is the original graph. So the new graph is just going to look sort of like this. It's just the original graph reflected in the x-axis. Right, so let's do a couple more over here. So what if the question said, can you draw y equals f of minus x? And the minus x was in the bracket. Can we draw that? Well, again, yes, we can draw that because f of minus x just means that expression with all the x's replaced with minus x. So when you replace all the x's with something, it's a horizontal transformation. Replacing all the x's with minus x, what does that do? Well, that reflects it horizontally, so in the y-axis. So this is the original graph. If you reflect it in the y-axis, what's going to happen? Well, this side on the left is going to move to the right, just over here. And the side on the right is going to move to the left. So nothing happens really, it just reflects on top of itself. And that's because for this graph, the y-axis is a line of symmetry. So it looks exactly the same. But replacing all the x's with minus x reflects it in the y-axis, horizontally. Right, let's do a couple more over here. Let's sketch y equals f of 4x. So what's that going to look like? Well, I'll just draw the original graph. The original graph looks like that. So f of 4x just means that expression, and we don't know what it is, but it just means the original expression, but with all the x's replaced with 4x. Now replacing all the x's with something else is a horizontal transformation. If you replace all the x's in the expression with 4x, the graph doesn't stretch by a factor of 4, it actually squashes by a factor of 4. Remember, with horizontal transformations, it's always the opposite of what you'd expect. So the new graph is going to be this graph squashed 4 times closer to the y-axis. This point's going to move to here and cross at a half. So it's going to cross at a half. This point's going to move to here and cross at minus a half, 4 times closer to the y-axis. So minus a half. This point's going to move 4 times closer. This point's going to move 4 times closer. This point's on the y-axis, so it's going to just stay there. So the new graph is the original graph just really squashed 4 times closer to the y-axis. If you did want the graph to stretch by a factor of 4 horizontally, you'd have to replace all the x's with a quarter x. So y equals f of a quarter x would be the original graph stretched by a factor of 4. Right, let's do one more down here to finish off. Last example, let's do y equals half f of x. So what's that going to look like? Well, again, let's think what this means. What does half f of x mean? It means the original expression with a half stuck at the front. So multiplied by a half, or halved in other words. So all the y values are going to halve, and the graph is going to just be the original graph squashed 2 times closer to the x-axis, because all the heights are going to halve. So this point at 0, 6 is going to move to 0, 3, so it's going to move down. I'll just draw the original graph, so it looks something like that. So this point here is going to move to 3 on the y-axis. This point here is going to move closer to the x-axis, over to there. This point's going to move up twice as close to the x-axis as well. These 2 points on the x-axis aren't going to move, they're going to stay where they are. So all the points move twice as close to the x-axis, in other words all the y-coordinates halve. So that's it.